So, what we're going to be doing is talking about simple harmonic motion. And we started this before spring break using that oscillating spring where you saw the mass on the spring bouncing up and down. You took a video of it and you had different masses on the springs. Then everybody needed to input their and these are all of the inputs for the various tracings that you did on your videos using, I believe it was Vernier video analysis. So in here, there are a few things that are not totally on par. Some of this being where people said, oh, hey, here's where equilibrium was, doesn't appear to be exactly in the middle. And we definitely had some of those off. But what you can see is that there is a definitive pattern. Okay, are we seeing that? We definitely are seeing these what are called sinusoidal patterns is the official word. So they look like sine or cosine all the way through. And these are different, all the different ones from everybody. But you can also see that there are some differences. Some of it, there were different amplitudes. Some of it, there were different periods. And that's 100% okay. So what I did, then you had to go through and you put in your amplitudes, your periods, and I compiled all of that data into a spreadsheet because yay, spreadsheets. And let me start with that spreadsheet. So we have this all here. I kind of reorganized it a little bit so that I put all of the different masses together so that the mass on the springs were all the same. And we can start to notice that there seems to be a real similarity is the best word I can say for it, between the different masses on the spring and the periods that ensue. So when we start to see this with the numbers and seeing it in the original chart, in the original table, it was hard to piece it all together. So a little reorganization and a little why not. What we're going to do is jump over to our chart. And when we see this, we see that plotting all of the points, we get an equation that looks like a constant x. Remember, that was mass. So the period is equal to a number times mass to the 0.412. And we kind of know now, by now, that when you see raised to the 0.4, you're like, that probably isn't 0.4. I'm betting it's probably the 0.5. So I went ahead and linearized it by graphing the period on the vertical axis, and on the horizontal axis we have the square root of mass, and you see we get a 0.95 0.975 r squared value, which tells us that our data matches the line very, very well. And we're now seeing this be a really nice straight line that we can know something about. So that tells us that there's a relationship between the period and the square root of the mass, and that there's a constant involved. So more to that in the next video.